Well, great. Well, hello everyone. Good morning, good afternoon, good evening, depending on your location. And welcome to the 11th edition of CELINE. That is the Circle of Neurocognitive Linguistics, sorry. The place where we discuss new ideas and their relevance for a new neurocognitive approach to the study of language. As most of you know already, our aim is to advance a little in understanding human language with each edition. My name is Paul Buzila. I'm your host. And as always, this meeting is being recorded, so that our friends who are not able to attend at this time can watch the recording later. Um, just to remind you, we started off last year in March as a small initiative supported by the Center for Comparative and Cognitive Linguistics at the University of Bucharest in Romania. And that's why we had our first meetings in Romanian. But lately we have transitioned to English as our CELINE community has slowly become international. So I would like to thank all of you, those who are here today and those who will be watching the recording later, for showing interest in the topics we are discussing. And although we are going to take a break over the summer after this meeting, we will come back in September with new topics and even interesting news, I hope. Um, I'm referring here to some projects we have started related to neurocognitive linguistics and which I hope will have some deliverables by the end of the year. And to which, by the way, if you wish to contribute, please let us know by sending an email to clcc at lls.unibook.ro. That's the same email from which you get the invitations to these meetings. If you will allow me just briefly to mention some of these projects here. We have an open call for contributions for a special issue of Análisis de Lingüística. That's a linguistics journal at the University of Cuyo, Argentina. That will be a special issue dedicated to Sidney Lamb's relational network theory. So if you are interested, please send us your article by the end of September. I think I sent out the call for paper about a month ago. If you don't have it yet, let me know, I can resend it. Then we are working on a neurocognitive linguistics website. That would be an, let's say, up-to-date online platform dedicated to neurocognitive linguistics. We wish to have it as a place where people can find information about neurocognitive approaches to the study of language, also bibliography, information on projects and people working in the field, but also as a platform for scholars and researchers interested in these kind of topics, so that they can be able to get in touch with each other. The site is under construction, and we could definitely use some help. So if you want to help, just let us know. For those of you who are students in Romania, because I remind you, this whole thing started as a student circle. This activity could also work as professional practice, practica professionale. You know what I'm talking about. All right. Also, I hope to be able to host a CELINE workshop at the University of Bucharest, which will be actually a special panel dedicated to neurocognitive linguistics within the annual international conference held by the Faculty of Foreign Languages at the University of Bucharest. And I will be sending a call for contribution soon. So as I said, I hope we can come back with exciting news about this project in September. And if you would like to get involved, don't hesitate to contact us. Now, coming back to our meeting today, as announced in the invitation, we have Dan Mailman with us today from the University of Tennessee, Chattanooga. Hi, Dan, and thank you for accepting our invitation.
My pleasure.
All right. Dan describes himself as a retired founder, CTO, computer scientist, adjunct faculty member, and current PhD candidate at the University of Tennessee, Chattanooga. Am I pronouncing that right?
Yes.
All right. His research interests include machine translation, high performance computing, and natural language processing. At the same time, he also enjoys camping, traveling, and exploration by bicycle or small row and sailboat. Through his hobby corporation, Studio Mindstride, he spins off ventures that produce specialized products for niche markets aligned with his interests. Currently, Language Genies focuses on global language input methods, while Gear Genies designs specialized outdoor gear. Also, he's developing software engineering courses to support underserved students, particularly those in NGOs, in NGO refugee sites, in achieving economic parity through software-based entrepreneurship. And if I understood it right, he's also an ex-student of Sydney Lamb's. So his approach to trying to understand language, I assume, has a strong neurocognitive component. Today, he's going to speak about one of his projects. I think, he has just confirmed it to me. It is his PhD project titled µLex Corpus-Based High Productivity Global Language Input Systems. So, Dan, thanks again for being with us today, and the floor is yours.
My pleasure. Thank you for having me.
Always.
Okay, so my my presentation is, as he said, on global language inputs.
Dan, we have just lost your audio.
How about now?
Yeah, now it's fine.
Okay, great. Okay, so there were two initial motivations for this project, actually outside of academia. I had actually started on a different project and then had an advisor leave the university, so I had to pivot. Um, I started on these a while back with two motivations outside of the university, and then once the high performance computing guy left this university, I had to pivot to something that was more uh, aligned with other advisor uh, expertise. So anyway, so the motivations were these. Okay, as you guys know, I studied with Sid Lamb for 5 years, and he was easily my very favorite professor. But my second favorite professor contacted me, maybe 10 years ago, and said that she had rheumatoid arthritis and was unable to use a keyboard. Okay. So, and asked me because she knew I was involved with languages and computers and said, "Can you solve the problem for me?" Right. So the when we talked back and forth, and I met with some uh, uh, rheumatologists and doctors to find out exactly what the problem was, and it's basically that her condition, rheumatoid arthritis, made it very difficult for her to use the knuckles of her hand, made it painful for her to use the knuckles of her hand. Okay, so in order to solve her problem, the problem was the solution, the best solution I could come. Actually, there were two, but if she were going to use her hands, which, you have a keyboard and you're a scholar, you're going to end up using a keyboard at some point. We want to minimize the number of times her knuckles have to move, minimize the number of gestures that she would use in order to maximize the number of characters that would be input for her documents, right? Okay. So at the same time, my daughter came home from school and said the teacher was making her handwrite her homework in Spanish so that she could get all of the accents right for the letters, which were not on the keyboard that all the kids were using at school. Right. And so I started looking into that as a problem. What do we do about all of those characters which are not on the keyboard? Even if you don't use an American keyboard, especially in our business, you're going to have to type characters that are not on whatever keyboard you're using. So the input problem had sort of two different directions. One is, how do you get hold of all of that stuff that's not on a keyboard, whatever keyboard you're using, right? And how do you minimize the number of gestures necessary to do your document processing, Word or Excel or programming or whatever you're using. So those are the two motivations, and they sort of came together into the idea behind µLex. Okay, so µLex is an input method. So input method, or IMEs, are software that enables keyboards to send non-keyboard characters to documents. Okay, so that's what we're trying to do. So if you're in Europe, you probably don't have access to easy Thai characters or Arabic characters or Japanese characters or Chinese characters. And if you're in those countries, some of the characters and punctuation that are used in Europe are not easy to get hold of from your keyboard. Okay, so there's a need, and it's not the need. It's not, nobody writes their dissertation on a mobile phone with their thumbs, right? So this is for sort of specialty markets. If you're a language student in a different country, then maybe this would be your product. If you're a scholar with rheumatoid arthritis, this would be your product. But it wouldn't be the one you use to text, to write your grocery list or something. Okay. All right. So this particular set of input methods, µLex, is going to live on a window on your currently Windows PC. That's 70% of computers in the world are Windows computers. So we're going to target the largest market. And there'll be a window that has the information necessary to do those characters, okay? And you can move that window to wherever is most convenient on your screen, okay? So, and it'll look like this. It'll be a grid of 8x4, or if you want, you can probably, this isn't currently available, so let's just say it's 8x4. And it will live wherever you want on your screen, and it will tell you what you need to do with your keyboard or your mouse in order to get the text you want in that language into your document. Okay, so I think this was actually my dissertation. Yeah, I'm pretty sure this was my dissertation I was working on. So any questions on what an input method is generally, and more or less what µLex looks like? Okay, and please feel free to interrupt. I prefer to have these things be interactive rather than me just babbling along. Okay, so what's the design? Our design goals are for a particular language, or any particular language. I started out with, for my dissertation, I'm focusing on Chinese because it's supposedly as different from English as possible. And one or two of my advisors are Chinese anyway, so I thought I'd do some impressing there. All right, so the design goals, you want to be able to account for every character, word, or phrase in the language. And obviously you can't do that because language is productive, but you can account for the most frequent ones, okay? And so that becomes an asymptotic goal. It becomes one we'll never meet, but we can get closer and closer, the better and better we are at analyzing the language. We can certainly do all characters because those are listed. Unicode is everybody should be familiar with what Unicode is, but Unicode covers something like 300,000 characters and 150 or so scripts, and those are the characters that we target. So if it's not in Unicode, we don't try. Okay, so we can get all characters easily. Okay, but words and phrases are going to be tricky and are going to be dictated by the language itself. And our source for the language itself is web pages in those languages. Okay. All right. And then we want to make that, because for the reasons already explained, we want to make the number of gestures to select a particular lexeme, and by lexeme I mean a word or a phrase in the language, as short as possible. Okay. And to make it so that the same gesture sequence selects the same output, selects the same lexeme all the time, so that your motor memory starts kicking in as quickly as possible, so that you're not actually looking at the thing as quickly as possible. Okay, your fingers already take over, and I'll show you how that works in the next few slides. So that's what I mean by deterministic. The same set of gestures produce the same output, the same lexeme every time. Okay. Then it needs to be easily learned and easily produced. Okay, so nothing confusing, or if there's any confusion, it disappears in the first 5 minutes or 10 minutes of usage. Okay, so so I designed a piece of software that hopefully accomplishes these goals, and moreover, because we're targeting people who don't necessarily um, or cannot necessarily use a keyboard accurately or easily, we make it as device agnostic as possible. And that's really more of a computer science consideration than it is a linguistic consideration. But for instance, you can use it with a keyboard, you can use it with a mouse, you can use it with a touch screen, and you can use it with a special one-handed uh, input system about which you can find more later in other papers that I've written. This is something I developed with the Australian Institute of Marine Science so that you can do all of your input with one hand while you're surfing above um, um, coral reefs on a sled. So anyway, but it turns out that a lot of people would like one-handed input devices, and so I've designed it so that you can use those devices as well. Um, uh, Special mice you can use, and a keyboard you can use. So the idea is to make it device agnostic. Simple selections, additional choices via related gesture, and I'll talk more about that later. And then the keyboard map, so that you can look at this thing and you can pretty much understand that for this particular interface, if you type a 2 or click on this um, screen or type just the thumb, right, of the top of your 5 fingers, you'll get that character. If you do the same thing for the bottom 3 fingers, you'll get that character, or you can type a D, or you can click here. And that should be, I hope, if I've done my job right, that should be fairly obvious just by looking at the screen. Okay, there's a letter, I can mouse over it, and there's a little chord map right there that shows you how to use your fingers. Okay, so anybody have trouble understanding that, or is it fairly clear, more or less? Okay, great. All right, so that's the design and implementation of the software. All right, so how do we get the most common the most common lexemes to show up first? Okay, that's the most common character that's typed in Chinese. There's obviously a most common character in English as well. Okay, so it turns out that if you go through all of the websites, the guys who did BNC, the British National Corpus, I think they went through websites. They might have used documents though. Anyway, there are thousands and thousands of frequency lists available to you in English, and probably for any language you want to find, there's at least one frequency list out there. So that gives you at least a place to start, right? So but you have to do your normal pre-processing too. There are things that you don't really want to pay attention to that the people who compile the frequency list do. So just for example, the token I in English is always capitalized. Okay, so we want to make sure that our input method accounts for that. Um, for instance, we're not going to take numbers or lexemes, or let's call them lexons, or graphemes, if you want to take. Okay, so in Sid's terms, right, the apostrophe D would be a lexon, right? And if you take lexeme and lexon and take it over to grapheme and graphon, these would be graphons, right? Um, so anyway, but although they occur frequently in this analysis, and perhaps a separate analysis, you could actually use the word that includes the apostrophe D. Okay, so there's pre-processing and conditioning that you want to do with any frequency list. The ampersand sign somehow made it into this frequency list. A small I made it into this one. A single letter made it into this one. The equal sign made it into this one, and some numbers. So you have to do some filtering in order to get the lexemes of interest. Okay. All right, and the same, okay, so that's the kind of problem you run into when you're talking about a punctuated language, or maybe an Indo-European languages all have these problems. So there has to be some intelligence applied as you get your lexemes for consideration for the application. Okay, and Chinese it doesn't have as many of the same kinds of problems, but it certainly you can see that in a Chinese lexeme frequency list, they do have punctuation that you have to not have to essentially filter out. Um, and the other problem for Chinese, Japanese, and to some extent Korean is that you not only have lexemes to deal with, but there are often individual characters which are not considered lexemes, which would be considered lexons as well, um, that you have to sort of meld into your input set. So getting your lexemes into processable order, okay, if for these languages, for Chinese, Japanese, and to some extent Korean, you have to essentially meld in two lists, a list of all the lexemes and a list of all the lexons or individual characters, which may or may not want to occur individually. Um, and there's something like 50,000 individual characters, many of which are never used in modern usage but they do occur in Unicode, and so you have to decide which ones of those you want to account for. So anyway, you do some intermediate processing, and at the end of the day, all you really need in order to produce the application is a list that has prefixes that are your keys, okay, that on your keyboard, okay, and a list of all of the things that you want to show up on the grid in order, in frequency order, okay. So this is one, and if you want to do statistics, you also need to include the frequencies, the accumulated frequencies for all of these items that will show up on the grid, okay. So you'll notice that there's no grid ID for the first one. That's because the most common ones are these, and they're the ones that are available in a single gesture, in the first gesture when this application is on. Okay, so for English, it's easier to understand. These are in order the most common lexemes in English, according to the BNC, uh, and the grid ID is nothing. That is, they're available to you immediately. However, if you type an A, then the ones that will be available to you are all of the ones in frequency order that start with the letter A. Okay, and if you type a letter B, they will be all of the lexemes that are available to you that start with the letter B, et cetera, et cetera. If you select the prefix AS, then it's all of the lexemes that start with AS in frequency order. And on down to the very last one is YOURS, and that could be yourself or yours. Okay, and these are available earlier as well, but you'll see why in a minute. We want them available all the way across. Okay, so this indicates the key, the prefix selections, and these are the lexemes which are available via that prefix. And this is all the information you need in order to produce the application. Okay, so for Chinese, the application looks like this. These are the characters that are available in one gesture. In this case, the gesture is indicated here. Um, and this is the character that will be selected. So now, how do we select this one, duh, versus all of the characters start with a? In this case, if we were mousing, we would short press, just click on that square, and we'd get duh input. And I'll show you how this works in a minute. Or we would hold it down. Okay, we're not double clicking because we want to minimize the use of knuckles. So we're doing a long press instead, right? Remember, we had one. This was designed initially for somebody who can't use their knuckles very easily. So rather than double click, which is a knuckle problem, right? We do short press versus long press. Okay, so that means for every one of these cells in the grid, we have two possibilities. We can short press or we can long press. Okay, and the short press is an input, is a lexeme, and the long press is a substitute grid. Okay, anyway, so this is all of the lexemes that are available in one gesture. There are 30 possible gestures. And that accounts for 33% of usages for our corpus, okay, for the Chinese corpus we use. Okay, a similar one. Okay, that you'll get A if you click here. If you long press this, or if you short press it, you'll get the choice of all of the letters that start with A. Okay, but these 30 lexemes, okay, account for 44% of the corpus usage. Okay, so with 30 memorizations, okay, you can in one keystroke type 44% of what you type. Okay, all right. So and in two gestures, okay, for both languages, it's approximately 70% of usages. Okay, so I mean, when you start to look at this, it looks like there's not much savings. But when you realize that you can type, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 characters with two gestures, then you start to see that your input efficiency really increases very, very quickly if you take the small amount of very reinforced effort to learn to motor memorize the gestures associated with each of these lexemes. Okay, and there are multi-word lexemes in here as well as, for instance, might be one. Okay, so anyway, in two gestures, you're covering 70% of usages, and in three gestures for Chinese, you're covering approximately 97% of the entire language that you might ever want to type, and in four gestures, you're an effective 100%. So with four gestures, normally something like this would take, I would guess, 15 gestures to type. Okay, and if it were rare, it would take even more. Um, for English, the words and phrases, there's some complexity involved, and I'll come back to this in a minute. I wanted to get the statistics down quickly. Okay, so for your initial usages, 44% is covered by those 30 lexemes. Okay, and that's only 1.16 of the tokens in the original in the original corpus. Okay.
Dan, I'm sorry. Can I ask a question now?
Sure, please do. Thank you. I
Okay,
thought.
so yeah, just to make sure I understood it right, when you have like the initial grid or any view of the grid actually, so to go to any particular square on this grid, is that also a combination of, like, if you have those four buttons device, the one that you hold in one hand, is
Yes,
like
that would be
the combination of two or three buttons takes me to one of these squares?
that is correct for
Okay, so
that
that would
particular
make
device.
one gesture.
Right. So
Okay.
there are 32 possible combinations of five
Okay.
things
All
taken
right.
1, 2, 3, 4, 5. So
And then
each
depending
one
on
of
the
those.
device you have, you have also combinations uh, of buttons or whatever.
Right. Right. Yeah. But the most common devices, obviously, the keyboard, the mouse, and the touch screen. So if
Mm.
you were to just click, whoops, just click on
Yeah.
that one, okay, then you get it. And because we're dealing with, we want to minimize knuckle usage for Peggy, right?
Yeah.
Rather than a double click, which you could do, or a left mouse click, or the other mouse click, right? If you have two buttons on your mice, we just do a short press versus a long press because many mice have only one button.
Oh yeah, yeah. That's clear.
Right.
Okay.
Okay. All right. So your
Okay. Thank you.
gestures, so the possible gestures on each cell are short press of the key, A, B, C, D, right? Long press of the key, A, B, C, D, short press of the mouse button when you're on the cell, or long press of the mouse button. Okay, so let's think of them as the primary gesture and the secondary gesture, right? Short press versus long press. And then short hold and release of the chordal device as well, if you wanted to use that one. The fingers, right? Okay, but I try to keep this to keyboard and mouse for the most part. Um, okay, so in the third, for English, we are at approximately 98% of usages, and in a fourth, you're at 99.89% of usages. And for English, given the complexity of the language, you actually have to go to a fifth gesture to get an effective 100%. But 99.89% is pretty close to effective 100%. And actually 98.3% is pretty close to 100%. So in 3 gestures, you're covering 98% of usages for the corpus, right? And 87, 88 percent of all the tokens in the corpus. Okay, so by the time so in 1, 2, or 3 gestures, you've got 98% of your of whatever it is you want to type covered, right? And that can be pretty long words like committee, community, and conference, right? So you can see that at least from a gesture standpoint, you get a very large efficiency here. Okay.
So again, then sorry, I'm trying to understand this at a very basic level. So what you are saying is that in 1 or 2 or 3 gestures, you can get to any lexeme you need, but you have to do this for each lexeme you need to compose your sentence, right?
That is correct.
Okay.
I think if I understand your question, that is correct. Yes.
Yes. Okay.
Okay. All right. So I have a demonstration that you guys can play with later if you want. All right. So now, okay. So actually, I'll come to this last because this is where I'm going to ask for help. Okay. So one of the other things I wanted to do, and this is not really a linguistic concern, but I'd like to get people thinking about this because this is the only thing I could come up with that was cheap that solves Peggy's problem. Okay, so the idea is that, and this is optional and just for fun, basically. Okay, so the idea here is let's see if there's a way to completely eliminate knuckle use altogether. Okay, well, it turns out there is. It turns out moving your shoulder and your elbow is all you need to do to move your mouse over each cell, right? So this is if you're using a mouse, this is only shoulder and elbow, right? So you're not using one of your finger joints for this. Okay, so then the only time you're using one of your joints on your finger is when you click and release the mouse button. Okay, but it turns out that humans also that there's no pain, no rheumatoid arthritis pain, if you rotate your forearm, right? So what I did for Peggy and what I'm trying to make generally commercially available is to essentially turn off the keyboard except for 2 keys, right? The space bar and let's say the enter key, right? And put your thumb on the space bar and put your small finger on the enter key and then use those as mouse buttons actuated by wrist rotation instead of clicking on your mouse button. So just for fun, and in order to not have to have people with this condition go out and buy a separate device, we can just give them an additional switch on this software that says use wrist rotation and 2 buttons instead, right? So anyway, I put that idea out there because many other people are more creative than I am. If you can come up with some other alternative that completely eliminates knuckle usage, then that's something I'm very, very interested in because it would help people, help the community I'm interested in serving. Okay. Anyway, so that's out there. All right. So of interest, probably more to this group is design time and making it better from a cognitive standpoint. Okay. So what I wanted to do is go over this view of the process, but after I've done a demonstration and shared something, and let me share. Actually, I can share this too. Is there a chat? There probably is here. Is that chat? Yeah.
Yeah, that should be on.
Okay. All right. That is the web page for what I'm going over now. Okay, so this is a demonstration that I'm putting up that I actually just put it up in the last week for this thing. So it doesn't have all of the features in it and it's there for discussion purposes. So I'd really love it if you go play with this thing and if you have any ideas about this, that would be really, really great. And also I'd like to do one of these for Romanian as well. So if somebody has frequency studies in Romanian, I can make a separate page for a µLex application for Romanian as well. So that's one of my requests for help is anybody's doing frequency studies for the language. I would love to do that. I would love to cooperate with you on doing one of these, not just for English, but for Romanian also, or any other language you have that you have a frequency list for. Okay. All right. So here's a demonstration web page that I'll be modifying as we add features to it and as we refine the strategy. But basically, how it works is this: if you press on, okay, so remember we have a primary gesture, which is a click, and a secondary gesture, which is a long press, right? So right now I'm just using the mouse, so I'm hovering over the cell, and you can see that it knows it's being hovered over because the outline changes briefly. If I do a short press, here, if I let's clear all of this first. Okay, this is where the output is going, is down here at the bottom. If I do a short press, I'll get an A. Okay, if I do a long press, the color of the cell changes to let me know the long press has been done. Okay, and then I get all of the lexemes to start with the letter A. Okay, if I see the one that I want, okay, I can just go click on it. Let's see, is there a noun here? I don't see any nouns at all. Action, but it really should be an action, but we'll just click an action. Okay, so then once we've selected our lexeme, I just clicked on it, right? Then it goes back to the beginning. Okay, so now action, let's say the next one that I want is the word heat. Okay, so I don't see it on here. So I know that heat starts with an H. So I long press the H, and it changes to that color to let me know it's been long pressed, right? Okay, and then I'm looking for heat there, and I don't see it. And I think it should be on here, but it probably isn't. I don't see it. I'm tired of looking for it. So now I type a long press an E as well, because that's the second letter of the one that I want. And I don't even see it there, and I'm tired of looking for it. So I go, actually, it is on there. It's here on the letter N, but I'm tired of looking for it. So I go ahead and press the long press, the third letter, and it'll make it easier to find. So then HEAG will select heat. Okay. Now I could also have selected it with H, H. Okay. Notice the change in color. Okay, E, change in color, and then it is on this screen, I think. Oh no, I'm sorry. It starts with an E, doesn't it? H, okay, E, H, E, A, T. Okay, so I could also have just typed an N here, and it would go. Okay. All right. So the idea here is that we're not going to force them to do visual scan all the way. We're going to give them, if they don't want to look at the visual scan for HE, okay, but they know it's HEA, then they can long press H E A, and that's as far as we take them, and then they can hit the G key. Does that make sense? Okay. Anyway, you can play with this. The idea is to make it as easy as possible in terms of visual scan and in terms of memorizing the gesture. Okay. So I posted this in the chat. You can go play with it. And these are the cognitive considerations that as nearly as I can tell, we have to come up with strategies for minimizing gestures, which I think I've already done pretty well. But also we'd like to minimize the time to find the lexeme in the visual scan, okay, to reinforce it often enough that you're no longer looking for it in the visual scan. You're no longer looking for the word you want from left to right because you've already memorized that R is by, and Q is that, and S is at, and T is R. Okay, so we can get these 30 that account for 44% of English. We can get those done pretty quickly because they're the most common 30 lexemes in the language. Okay. All right. So this is where I can claim to be a very, very, very good computer scientist. I can claim to be able to make a computer do whatever I want. I cannot claim to be a genius when it comes to the best ideas for making these things as efficient as possible. So that's where I'm looking for collaborators and people to make suggestions and people to just make this as useful as possible for the target communities. Okay. All right. So I find that it's useful to sort of think of it in terms of a cognitive process. Okay, and that is involved with the use of the software. Okay, and so that cognitive process is you choose your lex in your mind, right? You choose what it is you want to type. Okay, if you already have the motor memory down. Okay, remember this is designed to increase to maximize learnability. Okay, and by learnability I mean the ability not to look at the interface at all, because gestures, especially for the keyboard, the gestures are keyboard gestures that you should already that people type enough that they already know where the A key is. They already know where the B key is, the C key, the D key. Okay, so what we're trying to do is get motor memory down to the point where they're not using the interface for words that they type commonly. And we give them the ability to find those words quickly by making the most common ones the first ones they encounter in visual scan. Okay, so if you already know the motor memory, you just make those gestures, and every time you make those gestures, you're reinforcing your motor memory. If you don't know the motor memory, okay, then you do the visual scan, okay, and then you have to do that some number of times, right, for each of the first few letters, for each letter in the prefix that you cover, right? So, um, it'll take some amount of time to get the association between the alphabet and 1, 2, 3, 4 and the 30 most ones, but those should go pretty quickly. And then you don't have to do memorization for the first letter or for the first letters of the prefix, because all you have to do is long press those. So if you know it starts with HEA and you want to go all the way, or HE or H, okay, you can just long press that one and there's no memorization involved. Okay, so the motor memory step, the memorization step, is only in the last letter of the sequence. Okay, so for instance, for that heat, okay, let's bring it back. Okay, we know, depending on how much effort I want to put into gesture saving, okay, we know that it starts with HEA. So I know that I can go long press H, I already know where the H key is. Long press E, I already know where the E key is. Long press A, I already know where the A key is. And then it's only the last one that I have to do motor memory for, that I have to establish a new set of connections in Sid's terms, right? And that is G. So long press H, long press E, long press A, and then G. Okay, so I've already got that one down. So H, E, A, G. Okay. All right. So now head. Let's say H, E. Okay. And I want to do a quick scan because I don't see it there. A, D, A. Okay. So heat is H, E, A, G, and head is H, E, A, A. Okay. So that's two memorizations that I've done in the last 2 minutes. Okay, so it's harder to describe it, and this is often the case. Okay, it's harder to describe it than it is to do it, which is why I put the demo up. Okay, if you go up and you start playing with this thing, I hope that it will be as easy as I just did that for anybody else. And then if you have suggestions for optimizations or things that would make it easier to use, or well, or reasons it's not easy to use, um, then that information would be very much appreciated. Okay. All
So
right.
then,
Yes, I think
a small technical detail. So how is
yes.
this working on the keyboard? Are I
That
am I actually using the letters on the keyboard to go
you are
to the squares marked with those letters?
Yes, this
Okay.
key indicates the keyboard.
Okay.
Right. So one of the other possibilities, okay, that is under consideration is instead of doing A, B, C, D, we might want to do in keyboard order, okay, for people who don't already know the ABCs of their keyboard, right? We want to do maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Because those are the top row, right? And then QWERT, right? We may want to do uh, analogous with a physical layout of the keyboard. Okay, so that would be uh, I had in putting up this screen, I went back and forth as to which of those, but I went with what I know. I mean, I've been spent
Yeah.
so much time of my life typing that I went ahead and did ABCD because I know where those are. Um, but and then if we do 0 through 9, if we do keyboard layout, then it may not want to be 4 by 8. It may want to be 3 by 10. You see what I'm saying? So
Yeah.
to more look like a keyboard, and or we may want to make those options. Those are the kinds of things that I don't want to make decisions about unilaterally, because I'm just me, and I'm going to go with my own prejudices. Okay, but I'm not universal, right? So it would be much better to have suggestions and input and say, okay, look, if we can't win the argument as to whether this layout or that layout is better, then we have to make them options for the user, right? And that's why we're going to eventually have some real settings here rather than just a placeholder. Yes, go ahead, please, Mr.
Catalin.
Catalin.
For
Thank you.
me, it's very interesting, but the target is very, very, very niche. For me, it would be useful to give you like an advice that to transform it in a program for learning language for kids.
A very good idea. I will take that. Yes, an excellent idea. Thank you so much. Perfect. This is why we're having this meeting.
Yeah, going back to the different layout, I would say that from a neurocognitive point of view, uh, none is better than the other one, I think. And the restrictions you might have are related to the kind of population you're addressing it. Like as you said, some
Mm,
people might use their knuckles, some not. But as long as you have one way of doing it and consistently use it, it's about motor memory. So, and as you know, that builds up quite quickly.
yes.
So, yeah.
Yes. My tendency is to agree with you, but again, I agree that it
Okay.
should be.
Yeah.
Yeah, yeah.
Thanks.
Uh, but we could be wrong too. you know. All right. So let's see. Anyway, so this is available to you. My email address, I think, is probably available to you somewhere. Um, this is sort of the way I think of it when I think of it cognitively. I try to think about what the user has to do. They have to know what they want to type. They have to already know it, and if they don't, they have to do the visual scan, and they have to do that some number of times. Okay, and then eventually, if they do know it, then all they have to do is type the few gestures in order to get the character, the lexeme thereafter. Um, all right, so I can make this presentation available as well. Um, let's see, future investigation. I'm definitely looking for collaborations for products in other languages, because that actually was my very first love, is multiple languages and multiple language texts. Uh, with some of the electrical engineers in my university, we're working on different devices. But if you have an idea for one, I would love to hear it. You know, uh, specialty devices for people who can't use their hands, or people who don't have hands, or people who are paralyzed. If you can come up with any idea that you think would make it easier for any disabled community user to use this interface, I would love to hear those. I'm a pretty decent designer of mechanisms as well, and I have access to people who are much better than I am. um, and then there's always going to be a word that gets missed. okay, especially in specializations like we're all linguists. I'm sure that we all have a word that isn't in, that's not even used anywhere on the internet, but somewhere in one of our texts, we have that word. So it would be a nice way to, uh, come up with an elegant way to include our own words there. And then we also, because we are more specialized than most users, what is common for the internet, for a billion pages on the internet, may be a little less common for us. It would be nice if we could come up with a way of rearranging it so that we get our own custom interface too. But that's way down the line. And then any other suggestions that we can come up with, I'm completely open to it. The idea here is let's serve those communities as best we can. So for me, one of the focus is the people who can't use their hands, but another is, this is a great idea, is children who are learning these languages. This would give them, other than verbal reinforcement, right? So it essentially probably doubles their learning speed right away by having them type their homework in lexical terms rather than letter terms. I think this is a great idea. Would you tell me how to say your name again, please?
CELINE.
CELINE. Thank you very much for that suggestion. Their children in learning other languages is going to be one of our served communities from now on. Thank you.
I can contribute if it's possible. We can keep in touch.
I would love that. I would love that. I'm going to put my email address in the chat. Oops, in the chat. Will you send me an email so that we can begin collaborating?
Pleasure. Thank you so much.
Thank you. Any more questions? I went through this very, very quickly, and it's all very weird. So I'm happy to go over anything.
No, I think it was pretty clear. So if there are any questions, please go ahead. I have a couple, but I'll allow the other participants to go first.
I have a question. Thank you so much for your interesting talk. Are you thinking about increasing the program with verb flexive information, for example, with morphological information, so in order to build sentences, or is it difficult to?
I thought about that, especially for Japanese, because of all of the verb forms, right? But when I started looking at the web pages themselves and the frequency lists, so many of those forms are less used, and to the point where the frequency tends to fade. Well, in fact, it's obvious that the frequency favors the more used forms. So if we just do the complete lexeme, I think we're covered. But that would be that was actually my first impulse, as I say, especially for Japanese. So it would be a very interesting study to design one of these that goes morphological and productive rather than frequency based, and to see how many gestures we save. And even if we don't save gestures, if it increases the learnability, right? Because the same gesture is the same cognitive process, because cognitive processes are associated with the morphemes, right? It's sort of an open question for me whether that would be more productive than this. Okay, but this would be easy to use, and as CELINE says, this would also reinforce learning in the way that most teachers teach a language. You tend to focus on the more common phrases to get people conversational, right, rather than productive from a cognitive standpoint, which is not necessarily the way I learned, but it does seem to be the way teaching is going these days.
Okay.
I think it's a brilliant idea. I just I had to go one way or the other, and I went this way. if you're interested, I would love to see if we can't put together one of these for morphological strategy rather than frequency strategy. But you know, it would take time to get there, but only time and effort. You know.
Yeah. Thank you. Thank you.
I love the idea. I do. I love the idea.
Okay. Okay. Thank you.
Thank
So
you.
this is actually very similar to one of my questions. So if I could just jump in to make some additional clarification. So my question was basically related to the English version as it is now. And I was going to ask you, how does it work for a language like English, like an inflected language? Like how is the system at the moment making differences between inflected forms, like for verbs, between the present form or a past form? Are they just considered just different lexemes?
Exactly.
Based on the frequency? Okay.
Based on frequency. Okay. And
right.
I mean, right now there's still some processing we probably should do that may not be done. I actually use somebody else's frequency.
Just because like dance has a different frequency than dancing, I mean the whole system goes just by frequency.
Exactly so. Currently. Okay. Yes. But look, there are some.
Because then correlating with what Gisela said, there will probably be some, let's say, morphemes that you might want to consider separately and to induce, let's say, motor memory for those morphemes.
Agreed.
But
Agreed.
as you said, we would just need to check if that would be more efficient or not.
Right. I hate to say this, but it's so much easier to do it based on frequency than it is on morphological considerations. That's where I went first. Okay, but I mean, you know, we all have the same training, and we really would love these to be cognitive, right? So that, you know, you're selecting your object, and then you're selecting the tense, and then you're selecting the politeness level or whatever, each in a gesture. Okay. But the truth is, I mean, if you if you look at sort of Sid's research, they become portmanteaus so quickly that maybe frequency really is the way to go, right? Again, you know, it's an open question.
It's our linguist bias.
Right. So
which kids don't have, of course, and they still learn language.
Right. And they're not learning analysis as they're learning the language the way we think about it, right? So I'm inclined to think that this will at least, you know, get us down the road, even if it's not necessarily the most efficient or best way to do it. As I say, I would love, you know, once I get these out there and serving their communities, I would love to take a step back and try a cognitive one in some language or another. I think it's, you know, and I mean, I don't know if Japanese, even the Japanese people called Japanese the devil's language, right? You know, they've got 4 different scripts, right? And each verb has 4 politeness levels and 30 different inflection forms, right? So already that's 5 different gestures. So it is a temptation to put one of these together for that kind of thing. But again, we want to serve our communities as well. So let's get something out there quickly.
Okay, thank you.
A pleasure.
Any other questions? Well, if not, I'll go ahead with mine.
Okay.
All right. So the other question was, let's see how I phrase this. So this is basically, if I remember right, the syntax is a lexeme input system or something like that.
Lexical input system.
Lexical input. Okay. Yeah. So, and I see 2 levels at this, like the very technical aspect, which means the app, the devices you are using, and stuff like that. But then also the algorithm behind. And in your
Yes.
case, this algorithm is based on frequency,
Yes.
as you just explained. Now, referring to this algorithm, this might be a very dumb question, but I couldn't help but remember the famous case of Stephen Hawking and the way he used to produce language using that device. That in the last part of his life, I think he was also using an eye tracker. But leaving the eye tracking part or the hardware part aside, do you know by any chance how this system compares to the kind of system he used? Did he use also a frequency-based kind of system, or
I have
how would
no
this be
idea.
different?
Is he producing speech or text?
Well, he was producing text, but then he had some sort of converter with an automatic voice that would speak it out loud. But what he did basically was also going through list of words and picking the right word, but I'm
Oh,
not sure how.
I don't know either. There are devices, at least to the best of my knowledge, there are devices. I worked on this project way back when, that if it were speech, that um, map sequences of 2 or 3 gestures to English syllables, so that you're producing this sort of syllable by syllable speech, literally speech, right?
Uh-huh.
So it would pronounce those syllables for each of the for each combination of keys that you would press. So and that I've never actually seen Stephen Hawking in other than in passing, and
Yeah.
hadn't really thought about it. So I always assumed that's what he was doing, is producing syllables with keys. But I do not know.
Okay, right. Then let's just leave it aside because we don't know how it worked for him.
Right.
Then
I can look it up though. That'd be interesting.
then the last question that came to my mind as we were addressing the first one, actually, and the Gisela's question, would be related to how this system compares then, in your opinion, with what the LLMs are doing. Because let's put it like this: LLMs are working also on a sort of frequency of the linguistic forms they're using, right? So what's the
Right.
most probable form to come after the one that has just been added or something like that? I mean, is your system and the way it is based on frequency list different in any ways from the LLMs and on
Yeah.
how LLMs work?
Certainly, it's different from how they work because they have different goals. The purpose of an LLM is to determine your next word given a sequence of
Yeah.
words, right? And the purpose of this is to make it as easy as possible to type the word that you want to type, right? So this is single point focused, and that's vector
Uh-huh.
focused, if you want
Yeah.
to put it. So that's okay. But here's why you don't want to use LLMs in the back end of this software, right? Because they're always trying to predict the next word in a sequence, and that's going to be a different word depending on the previous sequence of words, right? And what we're trying to do is to get motor memory into the fingers of the users, right? So we don't want these grids to be rearranged every time,
Uh-huh.
right?
Yeah.
And that's what and that's the benefit, so-called benefit, that an LLM would bring to us. It would keep track of what we've already typed and give us, yes, the most likely word that we were going to type next, but how often is that actually going to be the word we want to type next, right? And especially given the degree of creativity for specialists, right? Um, that okay, so creativity predicts the degree to which you're not going to have the average expected next word, right? You're going to have a different word. Otherwise, it would be not creative. It would be just what everybody else has done, which is what LLMs represent. LLMs
Yeah.
represent a majority in some sense, right? Or at least a trained majority, right? Have I answered the question you're asking?
Yes.
Okay, great.
Thank you.
Sure, my pleasure. Yeah, I use LLMs when I want to write a program that I already understand. Okay, if I try to use LLMs to write a program from scratch that I'm just designing, it'll go way off into left field, right? So it's very good for doing things that my students could do. For instance, I teach programming here at the university, but very hard for any of what my colleagues would do, for instance, right?
Great. Are there any other questions?
Okay.
Yeah, just a short curiosity. What language is closer to LLM in sense of easy to understand and use for students? And what programming language is like Python or can be something else?
To the best of my knowledge, most LLMs, when it comes to programming, have been trained on Python programs. So its default language seems to be Python, but it does fairly well for me in R, for instance, and fairly well for me in C and C++. But I had the most luck in Python. Have I answered your question?
Yeah, for sure, because it's interesting how the new age of programming is going, because now, for example, people think that programming is not necessary anymore because ChatGPT can program by itself.
ChatGPT can write programs that have already been written, essentially, and variations of programs that can already be written. If I asked it to write this program, it would be hopeless.
Yeah, this I'm saying that it's important to underline this. And thank you for this talk. It's a fantastic. There are a lot of options in the future, like possible constructions.
Super good. That's what I'm looking for. So please, when the recording is available, please send it to your friends and make them watch it, especially the end where I ask for help.
I'll make it very clear in the email sending with the link. Please look carefully, and if you have ideas, please contact Dan, because
Lovely.
he's really interested in collaborations.
Yeah, thank you so much. That's great. We're gonna get some good stuff out there. Yeah,
For sure.
Okay.
Okay, any other comments or questions?
Okay, well, thank you very, very much for the opportunity to make this presentation, and I look forward to future collaborations.
Yeah, thank you, Dan, for this presentation. It has been probably the shortest but quite dense presentation.
Good.
So yeah, I'm really glad you could be with us. So thank you, Dan, again. Thank you all for being with us today. And well, I wish you all a great week ahead, a long and relaxing summer break, if that's the case. And I really hope to see you all in September. And as I said, I would send shortly the email and the link for the recording, probably tomorrow or in a couple of days. So I hope there will be more people wishing to contact you then, and some collaboration come out of this. Great. So thanks, everybody. Have a great day, and looking forward to our next meetings.
A pleasure.
Thank
you. Take care. Bye-bye.
Bye.
Bye.
Bye.